Hello, today we are going to learn basic operations on signal like time shifting, time scaling and time reflection or folding. So before going towards the main topic, we'll get introduced with the basic signals. These are called as elementary signals. There are a lot of elementary signals, but we will see only the singularity functions today. These are unit step signal, unit impulse signal and unit ramp signal. So as you can see, I have drawn these functions or signals. So first one is unit step signal. It's like a step. Its amplitude is 1. It is called as u of t in continuous time. So u of t is equal to 1 for t greater than 0 and 0 for t less than 0. See, here the values are 0. Here the values are 1. It is like a step. And in discrete time, we call it u of n. U of n is equal to 1 for n greater than equal to 0 and 0 for n less than 0. So you can see here it's also looking like a step. So it's called a step signal. Unit impulse signal. It is called as del of t. It's an impulse. So signal is 0 and suddenly it becomes 1 and drops to 0. So it's an impulse. Del of t is equal to 1 only at t is equal to 0, otherwise it is 0. For all the other values it is 0. Similarly, in discrete time, del of n is equal to 1 for n is equal to 0. You can see in this, for only 0, n is equal to 0, the signal amplitude is 1. Otherwise it is 0 elsewhere. Next is unit ramp signal. It's a ramp. Suddenly increase signal from 0. So r of t is equal to t into u of t. So you can see this definition similar to u of t, but instead of 1 here we have t when t is greater than 0. So its value is 1 at 1, t is equal to 1. Its value is 2 at t is equal to 2 and so on. So similarly in discrete time, r of n is equal to n into u of n. Its value is n for n greater than equal to 0 and is equal to 0 for n less than 0. So it's like a ramp. It's like a ramp increasing function. So these signals are very necessary for testing the characteristics of a system. So in operations also we'll need these basic or elementary signals. So we'll move to main course today. So the first operation we are going to see is time shift. Shifting in time. Okay. So we'll take a basic signal u of t. You know u of t is a step signal here. U of t. So we'll name x of t is equal to u of t and we want the output shifted signal as we want to find u of t plus 2. U of t plus 2. So this plus sign tells you advancement in the signal. So this is advancement signal. So it's 0, t plus 2, so it's an advance. So we'll move in this direction, move to the left side by 2 units. Now this signal is 1 from 0 to infinity. So we'll move like this. Okay, so this is u of t plus 2 advanced signal. Okay, now we want to find u of t minus 1. So minus sign denotes a delay operation. So delay is by 1 unit. So we will be shifting this signal on the right side by 1 unit. This whole signal u of t, we want to shift it on right. So this will be like this. So we'll name this u of t minus 1. So this is simple shifting operation, and we'll take one random example, random signal. In discrete time. Okay, so x of n is a signal like this. Suppose it is 1 2 1 minus 1. Okay, we want to find x of n minus 2. So we draw the same axis. Here it is n shifted by 2. So minus sign, so the signal is delayed by 2 units. So here it was 0 1 2 3 like this. So 0 1 2 3 4 and will go up to 5 because delayed by 2. So this will be like this. So this is your x of n minus 2. Now I want to advance this signal by 1 unit. X of n plus 1. Advance means shift it on the left side by 1 unit. 0 1 2 3 4. Here minus 1. So this sample at 0 will go at minus 1 like this. Okay, so this is time shifting operation. I hope you got this. Now we'll move to next operation, that is time scaling operation. In time scaling, we'll use another signal, a different signal. See, like this. We'll take a continuous time signal like this. Suppose this is minus 1, this is 1, this is 0, and this is 1. So this is your x of t. X of t, you want to find. So scaling first. Learn what is scaling. Scaling in time means the signal will compress or the signal will compress or signal will expand. So operation is done on t, multiplication or division on t. So we will first find x of 2t. Now x of 2t, when t is multiplied by this integer like this 2t, so the signal compresses. Okay, so now this sample at this point will come at, when this t is equal to 1, we want to divide it by 2. Okay, so this will come at half. This will compress actually. So 1 was here, this is 1 by 2. We divided this 1 by 2 for compression. Now on this side also we'll do the same thing. Compression is done by taking this point as a center. So minus half here, so 1 is here, minus 1 is here. So the signal is x of 2t. The compression, always remember, compression is done with this axis, y-axis at the center. Okay. So I'll take one more example. Suppose this signal, the same signal was like this. Suppose it was 0, 1, 2. Okay, now this signal is suppose y of t. I'll take a different name, y of t. If you want to do the same operation, y of 2t, so y of 2t, 0 divided by 2, so see this sample will remain here. 1 divided by 2, so this amplitude 1 will move to half, so half is here, suppose half, so this compression is like this 2 will come at 2 by 2, that is equal to 1. So the compression is taking the center, this y-axis. Okay, now we'll see this time scaling when this factor is dividing the time axis. So x of t by 2, so your x of t was like this, minus 1 0 1. Okay, this was your x of t, so how will be x of t by 2? So it will dilate the axis, so t by 2, so we'll multiply it by 2, so minus 1 will become, this point will become minus 2, this minus 1 and 2, this will be enough. Amplitudes are going to remain same in this operation, nothing will change, so this signal is x of t by 2. Okay, now we'll see next operation, which is time reflection. Time, or it's called as time folding. Folding means we are taking mirror image with respect to y-axis. So we'll take a simple signal u of t, so you'll find u of minus t as a reflection of this signal. So this signal will look like this, its amplitude is 1, it's not changed. So this is u of minus t reflected here on this side. Suppose you take r of t, like this. So r of minus t, that signal will look like this. This sample will be at minus 1, this is 1, this is 2, minus 2 and so on. So this is your, this is r of minus t. Okay, so these three operations are basic operations done on the time axis. Now we'll see combined operation. There are very complicated ways to do this operation by calculating actually the value of t in the modified signal, what will be the value. Okay, so there are many complicated ways, but we'll remember only this simple ways. Now we'll see combined operations. So in combined operations, we'll take two operations simultaneously done on a signal. So you are given find u of 2t plus 1, for example 2t plus 1. So here two operations are there, one is time shifting, one is time scaling. So first of all, whatever given, we have to perform shifting first. So shifting is the first operation. Sequence will be first shifting and second is a scaling operation here. Scaling. So these two actions are not commutative, so you can't exchange the order here. So first we'll consider u of t, basic signal u of t. We'll draw the signal. The signal is like this, u of t. Then you find u of t plus 1. So what is t plus 1? T plus 1 is advancement by 1 unit. So it will be like this, minus 1, 0, 1 and so on. Now 2t means scaling operation. It is compressing this signal with respect to this 0. So this signal u of 2t plus 1. We are writing all the things, now performing only this operation 2t. So taking this signal. Now this minus 1 will come at minus 1 by 2. So 1 is here, minus 1 is here, minus 1 by 2 here. So all the samples, this sample will come at this point, at 2 this will come at 1, like this. But this signal is infinitely long. Okay, so the final signal will look like this. We'll take a general signal and see one more operation. One more combined operation here. Okay, so we'll take a signal x of t, like the triangular signal we have seen. This amplitude is 1, this is minus 1, this is plus 1. Now it is asked to find x of minus 3t plus 2. Okay, so this is a very complicated operation where time shifting is there, scaling is there, reflection is also there. So we'll first perform shifting, then perform scaling, then perform reflection. Okay, so first it is advanced by 2 units, so we'll draw x of t plus 2. T plus 2, so this minus 1 will go to minus 3. So we'll draw the points first. This is minus 3, minus 2, minus 1, 0, 1, 2, like this. Minus okay, like this. Now scaling operation, second operation. This will perform shifting first, second will perform scaling. This is first, this is second, scaling operation. So scaling, divide by now 3, because scaling factor is 3. Now here we are plotting x of 3t plus 2. I'm not taking this minus sign, only I'm performing the scaling operation. So minus 1 will go at minus 1 by 3. This minus 2 will go to minus 2 by 3, minus 3 by 3. That point is minus 1. So this point is minus 1. Okay, so here I'll divide this into 3 parts. So this is minus 2 by 3, minus 1 by 3. Okay, so minus 1 by 3 to minus 1, and the top of this is at 2 by 3, minus 2 by 3. So this is your signal x of x of 3t plus 2. Now we'll perform the final operation, that is folding. Third will perform folding. Now this signal is x of minus 3t plus 2. Now take this signal and perform folding. So take reflection with respect to this axis. So this was minus 1 by 3. This point will go to 1 by 3. Minus 2.3 point will go to 2 by 3. Minus 1 will go to plus 1. Okay. Amplitude is same. It was 1. So uniformly it is 1. So this is combined operation. So always remember the flow. First you have to perform shifting, then scaling, and then folding. Okay. So very first shifting, then the other operations. That you remember. First shifting and then other operations. Thank you.